And now let me change my color to green. Now let's look at this point right here. What is that point right there? That point right there is what? That point right there, let me mark it over here. That point is x comma, and then y, but the line is 1/3 x. So this is y, x comma 1/3 x. We want to, by the way, we want this dx slices, and we want to solve for y in terms of x. So that point right there is what? Is x comma 1/3 x. So what that green point right there is the lower part, is actually, it's part of this line right here. This green line right here, the green line is what we call the inner boundary curve. So let me write down that this is the inner boundary curve. Again, the green line is what we call the inner boundary curve. Inner boundary curve. Inner boundary, okay? Let me call it this way. That is the inner boundary curve. And that point right there, that green point right there, which I marked in green, that corresponds to, if you have a line like this, it corresponds to this point right here. The red point which I marked is actually over here. And then now let's look at the third point. Let me mark this in blue. This point is right here. What is that point doing there? That point is part of this curve right here. And that blue curve, what is that? That is what we call the outer boundary curve. That is called the outer boundary curve. Outer boundary curve. Oops, boundary, outer boundary curve. Let me change that to blue. And so that is outer boundary curve. And what is the corner point of that point? What are the coordinates there? Let me mark it. So that point right there, so this point right here, let me mark it. That point is now what? X comma. And then this guy is y, which is square root of x. Now because this is dx slicing, everything has to be written in x. So this is dx slices. Everything has to be written in terms of dx, in x that is. So that's why the slicing direction is so important. Dx slices, that means everything has to be written in terms of x. So now let's see. What is the inner radius? This is the inner radius, r. So what is the outer boundary curve? Is what? The outer boundary curve is y equal to cube, y equals to a square of x. What is the inner boundary curve? Inner boundary curve is y is equal to 1/3 x. So what is the outer radius? The outer radius is what? Is square root of y equals square root of x, and then minus what is 0 right here. So what is the outer radius? The outer radius is from here all the way to here. That's called the outer radius. Outer radius is that. And then that will be from here all the way to here. That is called the outer radius. Outer radius is therefore square root of x minus 0. What is the inner radius? The inner radius is now 1/3 x minus 0. Y equals 0. This 0 right here is the rotation axis. That's the red. So basically that's the red. So let me mark this in red here. That's in red. That's the red. And then the green is over here, inner radius. Outer boundary. Y equals square root of x is because it's called the outer boundary curve. The outer radius is square root of x minus 0. The 0 for the rotation axis. Right now, the rotation axis is what? The rotation axis is y is equal to 0. That's why, okay? So this 0 right here is part of y equals 0. So we get this. So now we have what? What is integral? Integral from where? Integral from where to where? The integral from 0 to 9. Again, the slicing direction is x. So x here, very important, x here. Everything has to be written in terms of x. What is the outer radius? The outer radius is now going to be square root of x, and then minus 0. And then 1/3 x, and then minus what? 0. This is how the integral looks like. And if you simplify this, what does that become? That becomes, basically that becomes what? That becomes the integral. So this becomes the integral of what? Integral from 0 to 9. Then we have a pi here, pi, and then this will be x, and then minus 1 over 9 x squared, and then dx. That will be a volume. Right? Volume setup. Everybody, you follow me here? And now let's look at example part B. Part B is now y equals 3. Y equals 3 now. Y equals 3. So this time what we now have is, instead of this red here, what we have is, now we have the y equals negative 3 is over here. So now what we have is, let me now draw, how about this? Should I redraw this here? Let me see, what should I do? Okay, you know what? How about if I draw let's say a green or blue? How about if I use brown? Then let me use a thick marker. So let me save this, and then use a thick marker. The thick marker is over here. I'm going to write like over this. And this is the line y equals what? Y is equal to negative 3. Y is equal to negative 3. If you do negative 3, then how is the dx slicing going to look like? The dx slicing is going to go all the way here, and then now we have a point over here. So now what we have is that we have a point here, and then we will be using this point right here for the inner radius curve. This is the inner boundary curve, and that's the outer boundary curve. So now let's see, rotation axis, y is equal to negative 3. It's going to be a horizontal line. So that means we'll be cutting this way. The slicing direction is dx. Solve for y in terms of x. Everything has to be in terms of x here. Now, what is the outer boundary curve? The outer boundary curve is now going to be this one, y is equal to square root of x. That will be the outer boundary curve. What is the inner boundary curve? The inner boundary curve is still y equals what? Y is equal to 1/3 x. Now, what is that point over there? That point over there in brown, which I marked here, that point in brown is going to be x comma negative 3, because the rotation axis is y equals negative 3. So now, what is the outer radius? The outer radius now will be square root of x, and then what? And then minus negative 3. And then what is the inner radius? Inner radius is going to be 1/3 x. And then what's minus negative 3? So the negative 3 is coming from this rotation axis right here. So the rotation axis is negative 3. So you can now fill out everything here. So now what? This is now from 0 to 9 again, from 0 to 9. And then, you know what? You can fill out everything here. Yeah, already filled out here. Okay. Any questions here? Okay. Again, this will be a kind of ring 2 instead of this red point. Now we have a brown point. For this guy here, we have a brown point. Okay, that's it. Okay, now let me save this and let me clear all this. It's a real mess now. And so what we do is, now how about if I do, let's say, this one. Let's look at y equals 5. I'm going to do part 3. Let's do y equals 5 here. Okay, so how about this? I'm going to use the same chart here. This time I'm going to do y equals 3, or y equals 5. So what I'm going to do is y equals 5, y equals 5, so let's look at y equals 5. So y equals 5, how it's going to look like? So now, here's the curve. Oh, you know what? The rotation axis will be above. So let me now draw it over here, down here. That's y. And the curve is going to look like this. then it's going to look like this, right? And this point is y equals 3, and this guy is 9, right? Now the rotation axis is going to be over here. This is now the rotation axis. This is now what? Y is equal to 5. Y equals 5. And we are now going to rotate this way. So now what we're going to do is this. Take a cross section. Take a cross section here. Now at this point, this is at x. What points do we see? We see this point right here. What is that point? That point is x comma, that is what that point is, x comma, excuse me. That point is what? That point is x comma 5. That point is x comma 5. What is that point over there? What is this point? What is this point over here? That point is going to be x comma square root of x. Note that everything has to be written in terms of x, because this is what? This is dx slicing. This point right here is what? That is now going to be x comma 1/3 x. So this x comma 1/3 x, this is part of the outer boundary curve. This point right here is part of the inner boundary curve. And note that this is a rotation axis. So now let's see. What is the outer boundary curve? The outer boundary curve is the curve which is further away from the rotation axis. Note that in this case, the outer boundary curve is y is equal to 1/3 x. This y equals 1/3 x used to be the inner boundary curve for the other two problems. But now this time it is the outer boundary curve. Why? Because this is the curve which is far away, further away from the rotation axis. And then the inner boundary curve is going to be y is equal to square root of x. This is now going to be inner boundary curve. So what is the outer radius? The outer radius is going to be now the distance from this point right here to this point right here. And we always go top minus bottom. Therefore, the outer radius is going to be 5 minus 1/3 x. Inner radius is going to be now 5 and then minus square root of x. And both the outer boundary curve and the inner boundary, they should always be bigger than 0. Radius, we always want to make sure that they are positive. So top minus bottom, this is what we get. So this is now what? dx slicing. And so dx slicing here. In x ranges from where to where? From 0 to 9. What is the outer boundary curve now? The outer boundary curve is y is equal to 5. So that will be 5 minus. The outer boundary curve is 1/3 x. So we get this. And then what is the inner boundary curve? Inner boundary curve is, in the inner radius, it's going to be 5 minus and then square root of x. Any questions here? We get this. Any questions here? Does anybody has any questions? Is it too hard? Is it too difficult? In this case, if you do draw a cross section, it's going to look like this. So we have a small cross section. We actually have a large. Let's say we have a circle like this, and then we have another circle like this. Yeah, we have another circle like this. This will be the cross section. So that's because we are going to have a segment here. And in this segment is now rotated about this line, y equals 5. So the segment is actually going to look like this. And that segment is over here. That segment right here, which are marked there, is actually this segment right here. And then we have the 3 points right here. And this is the inner radius, R1, Ri. And the outer radius is the big one. So R1, the R in the radius is this right here, and R radius is this guy right here. This whole thing is R radius, R0. Okay? And I have all the points marked here. What is R1? R1, no, R in the radius is going to be the difference, is going to be square root of x minus 1/3 x. That's the, outer radius is the distance from there to there, from here to here. So that will be 5 minus 1/3 x right there. And then that will be the inner radius. 5 minus 4 of x. Any questions here? So this is a of x. Okay? Now this time, let me just use the same marker. Oops. How about if I use the same graph there? This time, let's look at the y. How about this? I'm going to look at x equals -2. Okay? Let's look at x equals -2. What about if the rotation axis is x is equal to -2? Let's look at this guy. X equals -2. X equals -2 is a line over here. This is a line x equals -2. It's kind of a mess here. And then we are going to rotate this. You know what? I don't think we can. I can share this. You know what? Let me just save this, and then I'm going to erase all this. Yeah. Okay. So now let me just do this again. This time, let me do x equals -2. X equals -2. This is how it's going to look like. We have this. I'll try to draw the line a little bit more quicker. And so we have this curve here, and we have this this here, and then the rotation axis over here. So this is the line. This is the y-axis right here. That's the x-axis. And the rotation axis is the x equals -2. We are going to rotate this about this line. And this line is x equals -2. It is a vertical line. The vertical line is the rotation axis. So we know that if that's the vertical line, the rotation axis, our slice is going to look like this. So we'll be rotating this segment right here, this slice, this way. That's how the solid is going to look like. And then the solid is going to look like a ring again. So that will be a ring. And so the ring is going to look like this. So let me make it a little bigger. Bigger. So it's going to look like this here. So now let me mark the 3 points. The 3 points are here. The 3 points which we have to mark are here. This point, and this point, and this point. Where are the 3 points? The 3 points are this point, and this point, and this point. Now, rotation axis, x equals -2. If the rotation axis is -2, that means we'll be cutting in this slices right here. The slicing direction is d what? dy, not dx. Excuse me? So the slicing direction is what? The slicing direction is dy. Everybody get this? The slicing direction is the most important item here. It's not hard. If you mess up on the slicing direction, the entire integral will get messed up. Is that clear? Slicing direction is very important in the entire chapter 5, not just for this section. It's important for every application problem where you have to set up the volume. Okay. Where we have to set up the volume, the slicing direction is very important. Okay, so that means we have to solve for x in terms of y. That means everything has to be written in terms of y. So now let's see, what is this point right here? This point is going to be, the y coordinate will be y, so let me put y here, and x equals -2. That point is -2. Is over here. Now the question is, what is this point right here? That point, now this line, it was y equals 1/3 x. But everything has to be written in terms of y. So now we are able to name this point differently. This point is now going to be y coordinate is y, and what is x? X will now be called 3y. When the slicing direction is dy, that means everything has to be written in terms of y. All the points on the diagram everywhere must be written in terms of y. If it's dx slicing, then that means everything has to be written in terms of x. So here, everything has to be written in terms of y. Now, what is that point right there? That point is about y equals square root of x. This used to be called y equals square root of x. And now, we want to express that in terms of y. So note that the y coordinate is y. What is the x coordinate? X is y squared. Looks like that is y squared comma y. So we now have identified this point right here is 2 comma negative 2 comma y. This point is y squared comma y. This point is 3y comma y. dy slicing, everything must be written in terms of y. If it's dx slicing, everything has to be written in terms of x. Again, the slicing direction is critical here. If you make a mistake here, you cannot recover. Then, if your slicing direction is different, then you cannot cover. You cannot possibly get the right answer. Impossible to get the right integral. All right? So df says you get this. So now, what is the outer boundary curve? The outer boundary curve is from here. The outer boundary curve is this guy right here. This guy right here is the farthest away from the rotation axis. So what is the outer boundary curve? The outer boundary curve is now x equals 3y. Everything has to be written in terms of y. Therefore, x must be solved in terms of y as well. And then what is the inner boundary curve? Inner boundary curve is x plus y squared. So now, what is the outer radius? The outer radius is going to be that distance right there from here to here, and that will be 3y minus negative 2. It should always be right minus left. Right minus left, that's always the case. Right minus left. And then what is the inner radius? Inner radius is going to be the same thing here. The distance between these 2 points, that will be y squared minus, and then negative 2. Yes. So you will see a double negative here. And then you can get the rest. You can get the rest of it. And this is integral from where to where? From 0 to 3. Not from 0 to 9. It is not from 0 to 3. Because if you look at all the slices lie from y equals 0 to y equals 3. Y equals 3 right here. Okay? You can fill out everything. It's all filled out right here. You can fill out. Any questions here, class? Okay, let me just do one more case and wrap up. So let me do this here. Now what I'm going to do is I'm now going to do one more case, part F. Part F here. Let's do part F. So part F, let me do the bottom here. The bottom. Okay, if you do part F now, the part F, what is this? This is x. The rotation axis, I'm going to make this as x equals 10. So in this case, where's the rotation axis? The rotation axis is over here. This is the 9 here. And then the rotation axis will be over here. This is x equals what? 10. Then now we are going to rotate this way. And so the point in question is over here. Now we need to have a point right here. That is now the point in what? On the rotation axis. So in terms of this is what? X equals 10. X equals 10 is the vertical line, so we have to cut it this way. The slicing direction will be dy. That means all the x's must be written in terms of y. So slicing direction dy. Okay? And then again, from where to where? From 0 to 3. What is the outer radius? Outer radius is going to be the distance from here to here. Now the outer boundary curve, what is that? The outer boundary curve is x equals y squared. This x equals y squared was the inner boundary curve in the other example. Now this y equals x squared is x equals y squared is now the outer boundary curve. And therefore the radius, outer radius is now going to be y squared minus y is equal to x equals negative 2. So this is now going to be the outer radius. Inner boundary curve is going to be what? Over here. This is x equals inner boundary curve is this guy right here. That's right. So the inner boundary curve is x equals 3y. So what is now inner radius? The inner radius is going to be, wait, am I doing this -2 here? Sorry. What am I doing here? Messed up the, actually, outer boundary curve? Outer boundary curve is x equals y squared is correct. Inner boundary curve is correct. This point right here is what? Is 10 comma x, 10 comma y. That's the point right there. And now, what is the outer, what? Okay, so you know what? Let's write this. What is the outer radius? The outer radius is going to be, the outer radius is going to be from here, right here, to here. So that will be x equals 10 minus x is equal to what? X is equal to y squared. And the outer boundary, the inner boundary, the inner radius is going to be 10. The inner radius is going to be from here to here. And to write the distance, what do? We always going to write right minus left. So therefore, 10 minus, and then this is what? Y equals x equals 10 minus x equals 3y. So this is 3y. And then you have to calculate this. Any questions here? Any questions here? Anybody has any questions? Is it confusing? I try to make things clear as possible. Okay. I think this way of naming the points and then drawing a cross-section circle like this, I think this is probably the best bet. Okay. This is A of y. Cross-section at y is A of y. And the 3 points which are marked here is these, but in this case, these are the 3 points here, depending on, which example, which problem you're doing here. For x equals 10, the 3 point for x equals 10, the 3 points will be this point, and the point on the line, x equals 10. That point there. And then when you compute the distance, it's always right minus left. We always want to make the outer radius be positive, and also inner radius be positive as well. Okay? So we want to say 10 minus y squared, not y squared minus 10. Okay? All right, now the time almost 9:50. Why don't we take a break, a 10-minute break? So we have a 10-minute break. So let's take a 10-minute break. So 10-minute break. Can you ask? Okay, 10 a.m. Okay, I'll be back in 10 minutes.